Hi everyone, welcome to Science with Mama J. Today we're going to be doing a lab. It's called Drive the Nail. And basically what we're looking to do is see how much energy it takes or which configuration takes the most energy to drive a nail into a styrofoam block. So we have a styrofoam block, a ruler, two plastic tubes, one long, one short. We have a long and a short steel rod, a long and a short aluminum rod, and of course we have the nail. So basically what we're going to do today is we're going to do several experiments on what causes this nail to go into this block. So we're going to take the nail and measure the distance. Now, there are a couple of ways you could do this experiment. You could do how many trials it takes to get the nail all the way down, or you can see how far it drives the nail with one drop. So we're going to do the second one. So here we are at 3.4 centimeters. Okay. So I'm going to document. Okay, and we're going to do the long steel rod first. 3.4 centimeters. And I'm going to use the short tube. And we're doing the long steel rod with the short tube. We're dropping it from the same height every time, right at the mouth. And we're down to 2.2 centimeters. Okay. We're going to do the same thing. We're going to make a fresh puncture here because since the hole is already established, we don't want to put it in the same hole. And we're now at, I went a little lower this time, 3.2 centimeters. And we're going for the long steel rod again, but this time we're going for the long tube. Oh. And we're down to 1.1 centimeters. Okay. Now we're going to use the short steel rod. And I'm at 3.3 centimeters. And with the short tube, we're going to use a short steel rod. And we're looking at 2.7 centimeters. Looking at this is 3.3. And we're looking at the long steel, the long tube, again with the short steel rod. And we're down to 2 centimeters even. Now we're looking at the aluminum. We are 3.2 centimeters this time. And we're looking at the long aluminum rod with the short plastic tube. I don't think I measured that. Let's measure it anyway. Let's see. Okay, 3.2, and I think I did say 3.2. But better to be safe than sorry. And we went from 3.2 to 2.8. And now we're doing the long aluminum in the long tube, and we're at 3.2 again. And we are down to 2.3. Now the last one is the short aluminum rod. And we are at 3.3. And we're going to start with the short tube and the short aluminum rod. And we went from 3.3 to 3.1. And now we're looking at the short aluminum rod and the long tube, and we are starting at 3.2. And we are down to 2.7. Okay, so I recommend doing at least 3 trials of this and getting the average of the trials. But let's go ahead and take a look at our data. So 3.4 minus 2.2 is a 1.2 centimeter difference. This is a 2.1 centimeter difference. This is a 0.6 centimeter difference, 1.3, 0.4, 0.9, 0.2, and 0.5. Okay, so taking a look at the data, first let's go ahead and compare the long steel rod to the short. Well, let's compare the individual ones. We can see that the long tube every time had a greater difference. So in the long steel rod, the higher the distance it fell, the greater the driving of the nail. So obviously the distance is falling from impacts the force. Okay, we see the same thing with the short steel rod. the height it fell impact the force. Same with the long aluminum rod and the short aluminum rod. So in all 4 cases, the height impacted how far the rod fell, or how much force, the rod impacted on the nail to drive it further in. Now, if we look at the long steel rod and the short steel rod, obviously, okay, in terms of the diameter is exactly the same. So it is about half the size, maybe a little bit more than half the size. So the long steel rod has a greater mass than the short steel rod. So now does mass impact height? Well, when we look at the long steel rod dropped from the short tube and the short steel rod dropped from the short tube, you can see that it definitely impacted how much of a driving force it has. So dropped from the same height, the short steel rod only had a 0.6 centimeter movement, whereas the long steel rod had a 1.2 centimeter movement. So pretty much double. And if you look at the long steel rod and the short steel rod using the long tube, it is a 1.3 centimeter difference to a 2.1 centimeter difference. If you look at the aluminum rods, you'll see the same thing. The long aluminum rod to the short aluminum rod, in the short tube, you had a difference of 0.2 to 0.4. Okay, so the long one showing the greater force. And again, in the long tube, you have the short aluminum rod in the long tube moved at 0.5 centimeters, but the long rod moved in the long tube 0.9. So again, definitely mass. Okay, as you see, the aluminum rods are the same as the steel rods. Okay, the diameter is the same. It's approximately half the size of the rod. So the mass of the aluminum rod is definitely, the long aluminum rod is greater than the short aluminum rod. Now, comparing the steel to aluminum, well, I can tell you the short steel rod has a greater mass than the long aluminum rod, and it shows in the results. If you look at the short steel rod, moving it through the short tube, it had a greater impact at 0.6 to 0.4. And the long aluminum rod had an impact of 0.9 in the long tube, whereas the short steel rod had an impact of 1.3. So mass and height definitely impact the force behind the driving of the nail. Okay, so we're able to see that those two variables definitely did impact how far the nail went into the styrofoam block. So I hope this lab was helpful. If you have any questions, please feel free to write something in the comments. Thank you for joining me today, and I look forward to seeing you in class. Bye.